smartphones instead of a laptop. So, I mean, the cloud changes the entire way on how employees work. And majority or most of the employees would be also working from the public internet, and some would also be working from the private network. Now, in the middle stands the DMZ, or the demilitarized zone. So basically, this is where the resources are provisioned so that we could allow users coming from the public network to connect to the private network, right? So ito yung common topology na meron tayo within companies. So to put that into a actual implementation, so this is how a parameter-based security is commonly designed, right? And it's commonly implemented. So again, you have your trusted network. Inside your trusted network, you have your employees, you have your printers, your file shares. So this trusted network can be also segmented into several networks. So let's say you have another trusted network for your servers, another trusted network for your databases. You could have, let's say, pre-prod, prod, UAT, dev networks, whatever man na network segmentation ang meron kayo. So you could design this as you want. Then on the right, or on the left, would be your public network, which is of course the internet. And then sitting in the middle would be your demilitarized zone. So here you might have your, for example, Exchange servers, VPN devices, firewalls, all of those, all of those technologies or infrastructure that we use to secure the perimeter, right? So our focus here would be to basically protect this network, right? So we have this wall or this DMZ zone to protect this network. Now take into example, for example, Bob, right? So Bob is, let me just delete this. Bob is, for example, working from home, right? He's connecting via the internet and goes through the DMZ zone via the VPN to access a particular file share. Okay, so once I'm connected to the VPN, I enter my credentials, I'm in. I can now access, the printers. I can now access the servers, the databases. And at the same time, we have Sarah. Sarah is a developer. Sarah is connected within the trusted network or within the private network. And Zara, being a developer, has 24/7 access to a production database. Okay, so this is, again, it is very common, right, within organizations. So now this is working. I mean, there's no problem with this. But what happens now if, for example, Bob's credential gets compromised? Let's say nasa Starbucks si Bob, nagsasend ng email, biglang may phishing attempt na dumating. Na biktima si Bob, naniwala siya dun sa email. So he entered his corporate credentials because naniniwala siyang mananalo siya sa raffle, for example. And then the identity gets compromised, right? So if I'm the attacker, if I'm the hacker, I now have the credentials of Bob. I now have his username and his password. And so what I could do is I could simply, get to a clean computer or a different computer, or I could even steal Bob's machine if I could. And then because I now know the credentials, I can exactly impersonate Bob, right? I can connect through the VPN, enter Bob's credentials, and then I'm in. I'm now within this trusted network. And from here, I can now do whatever I want. So I can, do lateral movement, for example. I can search for credentials within the network until I have found a privileged credential. If I have, let's say, a malware that I want to deploy, I can also release that malware within the corporate network. I could infect Sarah's laptop with a malware. And then if that malware, for example, also has the capability to steal more credentials, then basically I can also get Sarah's credential, and knowing that Sarah has database access, let's say full access to this production database, then technically I can now also compromise the database. I can now do whatever I want. I can do content exfiltration. I can, stay within the network undetected for several months or even years. until suddenly I have already what I want to get or I would like to exfiltrate. And then I can just go out of the network silently as possible, undetected. Okay? So, hindi natin alam. We think that everything is working normally. We think that we're secured. But actually, under the hood, marami na palang nangyayari. Marami ng data na exfiltrate, marami ng information ang nakuha ng various attackers just because Bob's credentials was compromised. And it has remained undetected. There was no proper monitoring. There was no way technically for us to check or to know that something is already happening under the hood. Okay? So this is what we have right now. Now, what's wrong with this model? Number one, of course, well, we couldn't say that there was no security, right? There was, of course, security. We had a perimeter, and we were safeguarding that perimeter. But what went wrong here, number one, would be we trusted the different boundaries, right? So going back to the diagram, we trusted the corp network and the prod network. We didn't do any checks anymore because we thought that whoever is connected to this network is clean, is authorized, and also it's not compromised, right? So panatag tayo na basta nakakonect ka dito sa network na to, okay ka. Then second would be malicious user lateral movement went undetected. Again, because there was no way for us to monitor these kinds of attacks. There was no way for us to monitor how credentials are being used. There was no way for us to monitor what are the permissions that we have against our different users, right? And then also, third point here would be permissions to access privileged resources inside the trusted network were not time-bound. So going back to Sarah's scenario, wherein she has 24/7 access to the production database, which is technically hindi naman dapat, right? I mean, kailangan mo ba talaga ng access dyan? Di ba, you only need access to a particular resource only when needed, right? So the proper practice actually would be we should have a time-bound approach towards providing access. If Sarah needs, let's say, 4 hours access to a particular resource, then we just give him 4 hours access. After 4 hours, that permission should be automatically revoked. Okay, so thereby denying everyone again access from this critical infrastructure. Okay, then the last point here would be, again, we lack proper monitoring. If we only had the proper tools to monitor the identities, the credential hygienes of our users, then most probably maiiwasan natin yung ganitong mga attacks. Okay, so here comes zero trust security, or the zero trust security approach. Now, zero trust actually, it's not a technology, right? It's not a software that you buy. It's actually a framework that organizations can follow in order to further enhance the security of their networks. Now, inside the zero trust practice, it actually has 3 components. Number one would be verify explicitly. Second would be never trust, always verify. And third would be assume breach. Okay, so we'll be going through them one by one. First up would be verify explicitly. What does this mean? So inside kasi the zero trust practice, dapat wala kang pinagkakatiwalaan, right? Kesyo CEO pa yan, manager pa yan, or normal na employee pa yan, dapat hindi mo agad pinagkakatiwalaan. There should be proper auditing, there should be proper monitoring of these particular identities and devices within the network. So constantly you will be hearing there should be verification of the resources, verification of the attributes of this user, the compliance of the devices, in order for you to be able to make contextual access decisions to various resources. Okay, so the principle here, basically the message here is that always authenticate and authorize based on available data points. What are those data points? It could be the user identity, the location, the health of the device, the application being accessed, the data classification of the document, for example, and for any anomalies that you might have or that the system might find out. Okay, so always verify. Second would be access should be time bound, right? So in the IT world, we have this concept of JIT, or just in time access control. Again, the concept of this is that if Sarah needs access to a database for just an hour or 2 hours, then technically dapat 2 hours lang yung ibibigay. After that, it should be revoked. So this this reduces the attack surface because no one is an admin eternally, right? If you look into various organizations, and actually this is very practical to some of my customers that I talk to. So parang domain admin ako eh. I'm an admin to this database or to this Active Directory server, and proud na proud pa sila that they are a domain admin, but technically that is actually a security vulnerability, right? So paano pag nakuha yung credential mo, then you're just basically giving the keys to the kingdom to this particular attacker. So you should not be happy that you're a domain admin, but you should be, you should have the capability to request for domain admin privileges as needed, and then it should be time bound. Second would be, second component of zero trust would be never trust, always verify. So again, the word verify is here. So in this component, basically what it says is that, sorry, can someone go mute? Okay, thank you. Okay, so here under never trust, always verify, what we're saying here is that every user, every device, every application, every traffic, or every request should be considered as untrusted, and then you authenticate as needed. Authenticate explicitly and authorize each request to the least privilege model. Okay, so if Bob is requesting reader access role on a particular file share, then before granting that access, you should first verify Bob's identity. You should also verify Bob's laptop or machine or device that he's using, what operating system, what version, what platform. Is the device clean? Do they have any malware inside it? Okay, and then once all of those have been authenticated, then you grant, of course, least privilege. If Bob needs reader access only, then grant only reader access. And of course, it should be time bound. Okay. Then third would be assume breach, right? Here, this is actually a shift in mindset. And this is very applicable to our managers, cybersecurity practitioners. Basically, I think this would apply to everyone within the organization, but also it has to come from the top level, from the CEO up to the managerial level. Everyone should have this kind of mindset. Wherein, basically what we're saying here is that always assume that a adversary is always present within your environment. So hindi tayo dapat panatag na secured ako eh, hindi ako ma-hack eh. Instead, dapat ang mindset natin would be, hindi ko sure kung secured ako ngayon. Hindi ko sure kung tama na ba yung mga implementations na meron ako para hindi ako mapasok ng attacker. So palagi kang nag-assume na palaging may loophole within your networks, within your applications, so that you are more proactive, in implementing security controls. So with this assume breach mindset, you are also able to minimize yung blast radius for any breaches, or you're also able to prevent lateral movements by, you have network segmentations, you have various controls for your users, devices, and also for your applications. And you are also able to verify the sessions that are connecting to various applications from start to finish. Now, of course, we recognize that this is kind of difficult, right? Especially if you're, let's say, a global organization running your business within, various countries. Users are connecting from various continents, and also various devices are being used. So that's why we advocate the use of automation, right? So there should be a tool that has the capability to do analytics that helps you determine the risk of a particular traffic via machine learning, perhaps. So these tools can greatly help you in implementing this kind of architecture or this kind of practice. Okay, so part of assume breach as well would be the principle of always logging, always auditing, always inspecting, and continuously monitoring all configuration changes all resources and all traffic within the network, and also any kinds of suspicious activity. So baka mamaya may mga virtual machines kayo running sa cloud, then binago na pala yung public IP or nag-enable na pala ng public IP, nag-add na pala ng panibagong storage, and wala kayong visibility on those changes, right? So there should be a way for us to log all of those changes, to know what's happening within our environment. Okay, so those are the three components of zero trust. Now, how do we now apply this on a conceptual model? Okay, so again, think about the parameterized architecture that Bob and Sarah are currently in, right? So that would fall under the data plane. So the data plane basically contains all of the applications, all the servers, all the users that are working together, that are connecting together, to do business, right? Now with the zero trust security model, we are adding another plane on top of the data plane. We call this plane as the control plane. Inside the control plane, this plane contains all of the components to make zero trust architecture work, right? So inside this control plane, we have various components, but the major ones would be what we call the policy engine, the data store, and the trust engine. Okay, so what are those components? Number one would be the data store. Yung data store would be, it will act as the source of truth for various components inside your control plane. So think of storing user activities, user information, device information, historical activities of a particular user. All of those should be stored in a data source. Okay, so for example, user information. Ano ba yung username ni user? Ano yung password? Kailan ba siya last nag-login? Ano ba yung location niya? Ano ba yung IP address na ginagamit niya to connect to my network? All of those should be tracked and should be stored within a particular data store. When it comes to device information naman, ano ba yung machine na ginagamit ni user? Is it a Windows, a Mac, a Linux device, perhaps an Android or an Apple device? Ano ba yung operating system? Ano ba yung build? Ano yung serial number? Ano ba yung versions ng applications na ginagamit ni user? So all of those again should be stored in a data store. And then the historical activity would be all of the activity logs, the analytics of this particular user, yung behavior niya. For example, this user logs in every day in Makati from 9 a.m. to 5 p.m. So that should be stored so that one day, for example, nag-log in si user bigla ng 12 a.m., 12 midnight, and the connection came from China. Because you have historical activity, then you now have a way, or you now have, a information to determine that, oops, baka this is a risk, right? Baka this is a impossible travel alert that I should look into, or baka this is a credential that was stolen, and then someone from China is accessing my network using this credential. So we now have a way to connect all of those data points because we have a centralized data store. Okay. Then next component of the control plane would be the trust engine. So the trust engine is the one responsible in doing risk analysis. How we do this would be basically this trust engine is able to come up with a risk score against a particular request. So if the higher the number, usually it means it's much more riskier. It's much more dangerous. So for example, if a user has a risk score of 10 out of 10, then this trust engine will block all connections coming from this network or coming from this user. Okay, so how you do this can be different ways. It can be a static rule that you define. For example, may mga policies ka in place inside your application that says from 9 to 5 lang pwede mag-connect si user. Only users from the Philippines can connect. Only Windows machine can connect to my application. So those are static rules that you define, right? Or it could be also dynamic. So of course, with the advent of machine learning and AI capabilities on the cloud, we can leverage these technologies to create dynamic rules based on the behaviors of our users. So from here, if you're making use of dynamic or machine learning capabilities, your trust engine can actually profile your users, and then it can also, it's learning from the training data, and then it can detect any kinds of anomalous behaviors based from the patterns that it has learned. Okay, so best practice in the industry right now would be to have a combination of static and dynamic rules, because we found out that it works much more better. Okay, so this trust engine and the data store are dependent from each other. The trust engine uses the information coming from the data store as the source of truth, and then from there it comes up with a risk score that will then eventually be passed to what we call as the policy engine. Okay, so the third component would be policy engine. So policy engine now will be the one responsible to make the final decision. Ano ba tong request na to? I-allow ko ba or i-deny? Okay, so before it makes that decision, it first gets data from the trust engine. It gets the risk score from the trust engine. It gets also data from the data store to fetch any kind of user information, device information, and whatever compliance or organization policies that you might have. Okay, so for example, si Bob is trying to access a HR application from a unknown device after office hours, right? The policy engine, number one, of course, the policy engine will check that is Bob a member of my organization? Is the identity of Bob in my data store? Then second would be, ano ba yung organization policy? Pwede ba mag-access ng HR application after office hours, or baka naman within office hours lang? And then ano ba yung device health nitong device na ginagamit ni Bob? Is this recognized? Is this a unknown device or an unenrolled device in my organization? So from here, of course, because the device is unknown, the policy engine will be giving a deny effect. Therefore, the request should be denied. Okay. Then last, of course, would be the policy enforcement. So the policy enforcement, basically, it's some sort of a component of the policy engine. It's all it does is it enforces the policy. If it's allowed, then the request will be enforced. Thereby, Bob will be able to connect. If it's denied, the policy, of course, will be enforced. Thereby, Bob will be denied. Okay, so there are some applications lang, zero trust applications out there that decouples the policy enforcement from the policy engine. Hinihiwalay nila. But most of the time, they're also considered as one, right? So, okay, so those are the components of zero trust control plane. Now, how does this apply to Bob and Sarah's scenario? Right, so going back again to the parameter-based security that Bob and Sarah has. Again, remember kung na compromise yung credential ni Bob, right? Automatic, I can now log in using VPN or whatever means. I can now connect to the trusted network. I can now do lateral movement. I can infect Sarah's laptop, and thereby also get Sarah's credential to access the production database. But with zero trust architecture implemented, this is now how security will happen. So Bob and Sarah is now considered part of a untrusted network, right? So regardless kung nasa corp network ka or nasa public network ka, palagi kang untrusted, okay? And then sitting in the middle would be your policy enforcement, and then you also have your trusted network. So yung trusted network mo would be, of course, the resources that your organization consumes. The printers, the file shares, the databases, the servers, all of those will be part of a trusted network. And those are the things that we would like to protect. Now, what happens if Bob, whose credential was compromised, starts to request access to a particular device or a particular server? For example, Bob is now accessing a file share within the trusted network. Now, because we have zero trust architecture implemented, then that request will go through the policy enforcement engine, right? then so inside the request, for example, this is the request. So date and time, Bob is trying to access a file share on March 12, 2 p.m. Wala siyang multi-factor authentication because na-compromise na yung identity. Yung ginamit na device ni user or ni attacker would be a surface device. Ito yung ID ng device. And then the endpoint being accessed is a file share. So that request will be passed on to the policy enforcement. Policy enforcement will pass that data to the policy engine and then will now be verified. So here, remember we have the data store. So on the data store, we are storing Bob's information and device information. So inside this data store, we have, for example, user data, which contains Bob's name, his employee ID, the device ID, the IP address where Bob is used to or is commonly connecting to, the location of Bob, and also Bob's role. Of course, with the role, we are tying up also the permissions that a manager could do, or the resources that a manager can access. Then we also have, or we are also storing the device data. On the device data side, we are storing the device ID, of course, the type of device. So let's say this is a Surface device. And then what's important here, or very critical here, would be yung last device